Section 6.5 is solving equations, but now we're going to look at equations that have radicals involved in them. So far we've looked at simplifying radicals, simplifying radical expressions, and performing operations with radicals, adding, subtracting, multiplying, dividing. We looked at binomial conjugates, where we have something like 2 plus radical 3 or 2 minus radical 5. Now we're going to take a look at equations that contain these radicals, but we're going to have to consider the same rules that applied in the past. Okay, to solve these. So let's take a look first, okay, at our do this. So to solve radical equations, we're going to first isolate. We're going to isolate the radical expression. Okay, isolate it, then square, or in general, we're going to raise both sides to the power equal to the index. And let's go through an example of what I'm saying here. So if I had something quite simple like this. All right? What's x equal to? Anybody? What's x equal to? You could either just do it in your head or you can actually solve it. It's clearly 4, right? Because the square root of 4 is 2. So there's nothing else that we can do. But how do you get 4 is the question. Besides seeing that a 4 goes in there. How do you get rid of a radical? You square it. Why is that again, Niall?
Because it's the square root, and square root times the radical times the square is just the root.
Yeah, there's really a little 2 here. That's what Niall's indicating, that it's a square root, not a cube root, not a fourth root. There's a 2 there as an index. So if we go ahead and square both sides, a square root and a square reduced to just x, and this becomes 4. Is that obvious? Okay, what if we had a cube root? Cube root of y is equal to 27. Oh no, let's make it 3. I'm doing it backwards in my head. What would y be then? 27, okay, because the cube root of 27 gives you 3. Now, think about it this way. Whenever you have an index, it's like you have a power, but you have 1 over that power. And let me go through what I'm saying. So if you have a square root, it's really the same thing as a 1/2 power. If you have a cube root, it's the same thing as a 1/3 power. If you have a 4th root, or in this case, let's say an nth root, meaning any integer for the index, it's really 1 over n. So, can anybody explain how, or show that this is true using one of those previous examples that we looked at? So for example here, when we had a cube root or a square root, think about an example with a square root and convert the radical to a fractional exponent. So the square root is really x to the 1/2. So if I asked you the problem, and say the square root of x is equal to 7. We all can figure out what x is right away. But think about this in terms of rational exponents with a fraction in the exponent. If you were to convert square root, convert it the way I just showed you with that simple rule up top, what would it look like on the next line?
7 1 times 1/2 x, or to the 1/2.
Which is to the 1/2 though?
X to the 1/2 power.
Okay. That's correct, because a square root is the same thing as 1/2, so we can start with that. What's the next line going to look like? How do I get rid of a 1/2 power, though? Mike? You don't multiply by 2. You're on the right track, Mike. The idea of the exponent multiplying by 2. Not by its reciprocal. Also on the right track. In the end, you're going to multiply by something, and it's going to be the reciprocal, but you're not physically multiplying right now. How did you get rid of a square root? What was the statement that you made before? To get rid of a square root, you do what to both sides? Square both sides. So think about it now with a 1/2 power. Square this and square this. Now, Mike, does it make sense now what you said, where you multiply? When you raise a power to a power, you multiply those powers. So what Mike was saying made sense. He was saying multiply by 2. But if you just say multiply by 2, I think that's putting 2 up front, right? So you're squaring this, So that when these two things are multiplied, as Will noticed, Will, what are these? These are reciprocals. And when you multiply by reciprocal, you get 1. So this becomes x over here. And what's 7 squared? As we said a minute ago, 49. So really, what's happening is this. When you're squaring a square root, you're really raising a 1/2 power to the second power. The same thing happens with a cube root. So let's look at an example of a cube root now. It's good to know where this is coming from, so you don't just, I guess, abide by the words I give you. So say this is true. What's the answer right off the bat, without doing any math? Anybody got the answer for me? 8, right? Because 2 times 2 times 2 is 8. So the cube root of 8 is 2. I completely agree. But let's say you didn't know that. You start by thinking of this as x to the 1/3 power, if you'd like. Write it as 2. Well, how do you get rid of a 1/3 power? You raise it to the 3rd power on both sides. And then as Mike said a minute ago, and as Will reiterated, those are reciprocals. And when you raise a power to a power, you multiply these two powers. So as a result, this becomes just x. And this becomes 8. Okay, but this right here, and I'm not going to make a big deal after this. You don't have to really do it every time. That's the reason. That's the reason why squaring and cubing and raising to whatever the nth power is works when n is the index. Okay, so again, if n is the index, n being any number, you raise it to that power. Okay, you raise it to that power. So let's go ahead and take a look at some examples now with this in mind. Okay, example A. The quantity 3x minus 1 equals 4. Clearly, you can't tell me what x is, but you probably can tell me what belongs under the radical. The square root of what number gives you 4? 16. So the radicand, 3x minus 1, is really 16, right? Does that make sense? That the quantity 3x minus 1 should be 16, because the square root of 16 is 4. So really, you could start by saying 3x minus 1 equals 16. But where did that come from? What did you do to both sides to get that? How do you get 3x minus 1 equals 16? Square both sides. So you don't have to always see it mentally. You could start by doing a little bit of work. So start with this. The first step is to isolate the radical. Well, it's already isolated, isn't it? So I don't have to go any further. For those, by the way, side note, for if you struggled with absolute value and you forgot to isolate sometimes, it's going to come back to kick you in the butt right now. So you need to write this down. Isolate the radical. Don't forget to isolate. You can't start squaring initially. Like part B, you can't start by squaring or cubing for part B. It's not going to work. You need to get the radical by itself in part B first. Okay, that means getting rid of the 2 as a coefficient for part B, getting rid of the 3 as an addend. Okay, all that stuff has to be gone before you can do anything. But part 1 or part A, it's already the way it is. So we start, as Will said, by squaring both sides, which tells us exactly what we would notice by just looking at the problem, that the radicand, 3x minus 1, has to be 16. At this point in time, what do we do? Luca, what do you got?
X equals 5 and 2/3. So 3x equals 17, and 17 divided by 3 is 5 and 2/3.
Okay. Again, either answer is correct, obviously. Now, they're the same answer. It's not like you're getting multiple answers, but there are going to be problems where you get multiple answers. When might that occur? Think logically. When might you get more than one answer? So I am. When you what?
You were saying situation that you find that.
Yes. What situation would you get more than one answer?
Is it when the other side of the equation is a variable?
Possibly. It's a good one. Very good. If this were equal to x and you squared both sides, you get x squared on the right-hand side. Definitely. What else?
You get like x squared equals 49.
If you have an x squared underneath the radical also. Good. So if there was an x on the right-hand side of the equation, if it wasn't just a 4, if there was an x there, you would have to square it, right? And then you get x squared, which gives you quadratic. Or if there was an x squared under the radical already. Now, that's one statement. The second statement I want to make is this. The answer you get will not always work. So what do you have to do with all your answers? Check them where now?
Original.
In the original, please. So you need to check every answer in the original. Every answer needs to be checked in the original. Now, for these problems, I would recommend just checking them. There are some trends you can pick up on. Remember how there were certain times it didn't work for checking with other examples we did, and you could pick up on a trend? I would just check them all for this sake. It's pretty easy to check. God bless you. If you check 17 thirds, it's really simple because the third and the 3 cancel, leaving you with the 17 minus 1, which is 16. Square root of 16 is 4, so that checks. It does work. Okay, but I would check all of these. How about part B? So part A was really simple. Let's take a look at part B now. I'm going to rewrite it. Hold on. So we've got 2 times the cube root of the quantity 2y plus 2, that whole thing, plus 3 equals 7. For those that don't have the prettiest of handwritings, which you know who I'm talking about, please close your radical if it helps. Take a look what I'm pointing at right now. I put a little mark right over here. See that little mark right there? That means the radical has stopped, or the square root is over. So I know that this plus 3 is on the outside. Some of you have lines that just go on forever, and I can see that causing an issue. This 2 is clearly in front. It is not an index. You would never write 2 as an index. If there's nothing there, it's assumed to be a 2. There's clearly a 3 there. So step 1 is to isolate the radical, just like everything else. Think of this. If you're confused, think of this as the following. How would you solve for u in this case? Mike? You'd subtract the 3, so let's subtract the 3 from up here. I'm going to skip the red line. Just think of this on the side. Okay, I would subtract the 3, which would give me 2. Cube root of 2y plus 2 equals 4. Next, Mike?
And then you divide the whole thing by 2.
Divide by 2. So you'd subtract the 3, which gets rid of it, and then you divide by this 2 to get rid of it. Now do we notice that the radical has been isolated? Okay, this is the radical, it's by itself, so it's been isolated. Now we have to think back and say to ourselves, a cube root is really this. And you don't have to write this every time, but I just think of it this way. That's what a cube root really is. So how do I get rid of the 1/3? I raise it to the 3rd power. Okay, so cube both sides. Now again, you could have done that in this line right here. You don't have to rewrite it in red the way I wrote it here. Okay, you could cube here, and you get the same exact result. And at this point, once you get rid of the radical, you have a simple linear algebraic equation. Subtract 2 to give you 6, divide by 2 to give you y equals 3. Now, for this kind of a scenario, just check that you're correct, make sure. Take a 3, plug it back into the original. I'll give you a minute. Go ahead and check that, please. And remember, when you're checking something, you cannot move things around. You need to check it in the original and just simplify. You can't add things to one side of the equation. Again, you can't move things on either side of the equation when you're checking. You need to put it in the original and simply simplify. Don't move things back and forth on each side of the equation when you're checking. I'm going to check it also so you can see. So here's my check. And again, the question is this statement true? I cannot move stuff, so just simplify at this point. Just simplify. 2 times 3 is 6. 6 plus 2 is 8. The cube root of 8 is 2, making this 2 times 2 plus 3 is 7. That is true. 4 plus 3 is 7. Okay, so you're literally just substituting in and simplifying. Please don't move this 3 over. You cannot move things in a check. A check is to see that both sides of the equation are true. If you move something incorrectly, you might get a true statement when it's not really true. All right? Let's take a look at part C. Part C says the following. The square root of 18x squared minus the square root of 2x squared plus 3 is equal to 11. Is the square root isolated?
No.
Definitely not. Why is it definitely not this time and not just no?
Because there's 2 square roots.
It's 2 square roots. The question is, which square root am I even talking about, right? So the square root is not isolated. Let's get rid of that 3 first, right? Make life easy on us. Get rid of the 3. Then? And you don't have to worry about getting rid of x, by the way. You could take x out in both cases, but you don't have to do that in these cases. You really don't. You'll see why.
18x squared and took out 9, I think 2x squared.
Very good.
3 squared.
I agree with Luca. I would break 18 into 9 times 2. Why 9? Why 9? It's a perfect square. Okay? It's a perfect square. It's what we did last chapter. So we're going back to the stuff from last chapter now. Now, what we have to do at this point is to consider the fact that radical 9 is really 3. We have to go back to think about our radical rules. Remember, treat radicals like they're variables. So this is like saying, and this is what you need to look and remember, this is like 3 times u minus u equals 8. 3u minus 1u is how many u's? How many u's? Anybody ever seen My Cousin Vinny? It's an old movie. Oh, it's a funny movie. Have you seen it, Nick? It's with Joe Pesci? Yeah, Joe Pesci. It's really, but he always says utes. All utes. You utes. Yeah. So all U's, I was making a really bad joke. So 3 times some quantity minus, there's really a 1 here, times some quantity is really 3 times a missing minus 1 times a missing, meaning there are 2 of those. Okay, so transform this into this if it helps. Think of it that way. Okay, whenever anything is confusing, when there's a radical that's a little bit funky, just think of it as a given dummy variable u. This makes this 2u equals 8. But clearly it's not u that we were working with a minute ago. Okay, u is really radical 2x squared. All right, again, because I called this u earlier, and I called this u, I'm replacing u back with what it really is. The goal is not to solve the question for u, it was to figure out x. So 3 of these minus 1 of these gives us 2 of these. Now, how do I get rid of the 2 out in front? Divide by 2. And then, and only then, has the radical become isolated. Okay, so divide both sides by 2, giving us a 4. Square both sides, making this 2x squared equals 16. Divide by 2 again, giving us, making x equal to, what's the square root of 8? Simplified? You should be able to do this in your head by now. Come on.
4 root 2.
Root 4 times root 2.
That's what I said.
You said 4 root 2. It's root 4 times root 2, which simplifies to what?
2 root 2.
2 root 2. This one should literally be memorized at this point. Okay, you should see this enough. Now, what should I put out in front? I took a square root and I'm solving an equation. What goes in front?
Actually, 5.
What's the square root of 16, everybody?
Or
Or, if I'm solving an equation, it could be.
negative 4.
So what do I have to put in front of here?
Negative.
What's the symbol? It means both.
The plus negative on top of each other.
Yeah, plus or minus, positive or negative. Okay, this needs to have a plus or minus out in front. Okay, so again, the square root of 8 is really plus or minus 2 radical 2. All right? Whenever you solve an equation, you should have this in the back of your head already, because we did this in section 6.1. Section 6.1 started off with the statement of, well, if we had x squared equals b, how do we solve it? Okay, well, we have to think about the fact that if it was 49, x can be 7 or x can be negative 7. Remember, when you're simplifying something when it's an expression, this is an equation. When it's an expression, it just says radical 16, you're looking for the principal square root, which is just 4. But if there's an equation that said x squared equals 16, it's 4 or negative 4. So there's always 2 answers because this is x squared. Remember, quadratic, we said a minute ago. What's your name again, James? Joseph. Joseph gave us the statement earlier about the fact that there's going to be 2 answers here if we had like an x on one side. And then I think it was Mike, was you that said the other part? If there was an x underneath it. okay? Or if there's a square term or anything. The idea though is when it's squared, you're going to get two answers. Now, we have to go ahead and check both of those answers. So we have to check 2 radical 2, and we have to check negative 2 radical 2 in the original. Okay, let me show you one of those checks real quick so you can extrapolate some ideas from it. So the original statement was this. And I'm going to put 2 radical 2 wherever I had x. All right, so here's my statement from earlier. And I have a 2 radical 2 where I had x. So this is where x was in the original equation. I'm going to check this right now. Can somebody make some sort of a statement, though, about the second check that we have to perform? Just based on looking at this, can you make a statement about the second check that's going to be performed after this? Sabine?
The answer's going to be the same. because
Why?
You square the x value, so it's always positive.
Yeah, remember, the next answer we're going to check, isn't there going to be a negative here? And a negative here, is that the other option? Negative 2 root 2? Well, aren't you squaring that, though, in both cases? So Sabine makes a very intelligent statement. Why check twice? Once you check the first time, the second one is guaranteed to work because it's the exact same numbers. The number's the same, it's just a different sign. But since you're squaring it in the check anyway, you're squaring a negative, which makes it positive, so it has no effect on the outcome of the check. So please don't check it twice. It's wasting your time again. Okay, don't waste your time. So this becomes 18 times 4 times 2 minus 2 times 4 times 2 plus 3 equals 11. Please remember, for those of you that are forgetting your rules, this square goes to both of these. You square the 2, becomes a 4. You square radical 2, becomes a 2. So I'm showing the steps right now. 18 times 4 times 2. 18 times 4 is 72, times 2 is 144. Convenient, right? 2 times 4 times 2 gives me 16. Convenient again. Why am I saying convenient? Because they're perfect squares. Okay, because they're perfect squares. Radical 144 is 12. Radical 16 is 4. Remember, when you're checking, these expressions are simplifying. You're not solving an equation, correct? Remember, when you solve an equation, it's plus or minus. But when you simplify something, you just use the positive root. This minus gets carried down, obviously, because it's subtraction, but you use the positive root. Okay, then you put a plus 3.
Wouldn't it be 11?
Say again?
Wouldn't it be equal 11? You lost one of the ones.
I lost one of the ones. Thank you. Thanks, now. Okay? Because that wouldn't have checked out, right? 12 minus 4 is 8. 8 plus 3 is, as Niall just corrected me, 11 and not 1. 11. Okay? So again, the idea for this problem is that you want to check both of them. But you don't need to check both of them in this scenario because you're squaring the other answer, which was negative. If you ever get 2 completely different answers, like say you get 2 answers for a problem, x is 2 and x is 7, you got to check both. Okay, you definitely have to check both. But when you get answers like plus or minus, right, like plus or minus radical 7, it doesn't make a difference either one, because you're going to square it anyway in this circumstance. Okay, the last thing I want to really emphasize is the simple fact that when we took a square root of any of these numbers here in the check, we simplified with just the principal square root. You can't do plus or minus here. It wouldn't make any sense. How could you check it if you didn't know whether to use plus or minus? So write a little note at the bottom. When you check a radical equation, use the principal square roots in the check. When you check a radical equation, use the principal square roots in the check. That's why we didn't use a negative 12 here or a negative 4. It was a positive 12, then a positive 4. Again, the minus comes from the fact that it was subtraction, that's all. Any questions on this so far? I think I'm going to pause there. That's why I'm asking this. Any questions so far? All right, flip real quick to your homework. I want to emphasize some that you can actually work on so far. All right, so we've squared both sides. X minus 4 and x minus 3. All right, so we have 2 answers. Which of them is correct? Which of them is correct, 3 or 4? Niall, which one's right?
Um, 3.
3? All right, check it. Go back to the original. Plug in a 3. What do you get?
3.
You get 3? How?
Is 7x is 21 minus 12 is 9 and square root minus 3.
Very good. I just wanted you to say it so we know. Good. So we get root 9 is 3. What about the other one? Check the other one. It also works. What do you get there?
7 times 4, that's 28 minus 12, that's 16, and then 4 is 4.
Good. So in this case, both of these answers do still work. Okay? Both of these answers do still work. When do you suppose it may not work? Try to think. In this case, they both work. When might it not work? Good. If it makes under the radical a negative, rather, I guess. I mean, if this was negative, it's not necessarily going to be a problem, because you have plus or minus still. If you put a negative that makes under the radical negative, though, it would clearly be imaginary, right? It wouldn't work. And we haven't gotten into imaginary yet, which we will in like a section or two. It also wouldn't work, I'm trying to think. Well, we'll get to that example for part C. I want you to see it first. Because one of these examples coming up, if you have two radicals at the same time, we're going to see if that's going to cause a problem as well. Let's take a look at part B, though. Okay, so part A is 4 or 3. Let's look at part B. 3 times radical x plus 1. Minus x equals 1. All right, now, so far you've been told isolate the radical and then get rid of it. So how do you start isolating the radical? Just start isolating it. Don't actually isolate it fully. Mike? Yeah, add the x over to start. All right, now, think logically before you always take all my advice. My advice of isolating the radical is usually useful, but here, how would you get rid of that 3? How would you get rid of that 3, Nina?
Divide.
You'd have to divide. Now, it might make your denominator messy. You might just put this over 3 and make it a little bit annoying. So in reality, you could leave that there in front for now. You could do that. You could leave the 3 there, and you have this statement on the right-hand side. You could square both sides right now. But if you do that, you need to be very careful about how you square this in the proper way. So think about this for a second. If I leave it on the left-hand side, when I were to square, like, if I had xy in parentheses, xy, and I squared that, what does that really mean? How do you square a product? Mike?
Xy squared. Is it just xy squared?
Not xy squared, no.
X squared is squared.
X squared y squared. Again, if you have the quantity, side note, on the top right, if you had this squared, you would make it x squared y squared. Right? So this here, you have to square the 3, and you have to square the square root. 3 squared is just 9, so that goes in front, and then the square root just drops off. So sometimes it's easier not to isolate the radical if it puts this number in a denominator, which then you'd have to square the denominator anyway, which would put a 9 down here anyhow. So if you had divided by 3, you put a 3 down here, and you'd have to square that, which would put a 9 down here, and then you multiply by 9 to get rid of it, so it'd be back up here anyway. You follow what I'm saying right now? Dividing by 3 would put a 9 down here, because you'd have to square this side when there's a 3 there. And then you'd have to move it back up anyway. So the extra step isn't worth it. How about when you square the quantity 1 plus x? Be careful.
1 plus x, quantity 1 plus x, times the quantity 1 plus x.
Very good. And this is where you can clearly see your two rules differing. This over here was a square of a product. And you distributed the square to both, right? Here it was a square of a sum. And when there's a sum or a difference here, you do not distribute the square, yet you write it twice, as Niall just mentioned. Because now we don't want to forget that middle term. So we get 1 plus x, which is 2x, plus x squared. At this point in time, what should I do? Mike?
Factor what is it?
Factor x out. Where?
No, I said factor.
Oh.
Wait, oh, wait, sorry, you can,
If I factor, I go back to what I had, right?
yeah.
What should I do before I factor, Mike? Factor is the right choice, but you have to do one thing before that.
Should you distribute the number?
Yeah, let's distribute that 9. That might help us a little bit. And then Ryan, what should I do next?
Move it over.
Yeah, move it over. Okay, move these over here. Subtract 9x and subtract 9. Giving you 0 equals -8 minus 7x plus x squared. I'm going to rewrite that, obviously, so it just looks nice. Make it easy on myself. Factor, please. Factor. Kelly, factoring.
X plus 1.
Expert.
X quantity of x minus 8.
X plus, what was the first one?
X plus 1 times the quantity of x minus 8.
All right, plus 1 minus 8. Plus 1 minus 8. Again, the other options are 4 and 2, but 4 and 2 don't add up to 7 by any means, but 8 and 1 could add up to 7, and we want a -7, so we put a negative there and a positive there. Okay, giving me 2 answers. Now, how do I know which of those answers is right? What do I always do?
Plug it in.
Plug it in. Good. Plug it into the original, make sure. -1 and 8 need to go in the original statement. So I'm going to have to rewrite that original statement down here at the bottom. Is this backwards? Yeah, let's put this one back here. What was the, I don't have my notes in front of me. What was the original equation?
3 times the square root of x plus 1 minus x equals 1.
All right, so let me try the 8 first. Try the 8 first. If I plug an 8 in here, I'm going to get 8 plus 1, which is 9 right in here. Square root of 9 is 3. 3 times 3 is still 9. And 9 minus 8 is equal to 1. That is true. That works. After that, we can try the -1. If we try -1 in here, we get 3 times square root of 0 minus -1 equals 1. It's going to give me 0 minus -1 is equal to 1. That is true. Because a minus negative is a positive, that's also true. So these both work out for this scenario. Okay, they both work out. Try part C and think about what you would do to start part C. I'll give you like a minute or two to think about that one. That one's a little bit trickier. What would you actually do to start part C? It's really messy, part C. All right, I'm going to jot down the third example here and see what we've got. So radical 2x minus 2 minus radical x plus 6 equals 1. What would you suggest here, Kelly? Go ahead.
Well, if you square everything, you would just get 2x minus 2 minus x minus 6 equals 1.
Be careful.
And then,
Somebody, I got to pause you there.
what?
I got to pause you right there. What's the one mistake that unfortunately Kelly made there?
Shouldn't it be plus x plus x?
No.
Can't you third adding, or what is it? I forgot what the word is for subtraction. You can't just.
Yeah, you can't square terms. Here's what you could do, Kelly. Mathematically, you could square both sides of an equation always. But you can't square, these square roots don't cancel with this squared, because there's a sum in the middle there.
Sorry, I copied it down wrong.
That's all right. It's fine though. I'm glad that actually brought that up, because that's the first step that most people would think. Square everything, right? And it gets rid of both your square roots, and it makes it one squared. But we got to be careful with that one. We can't square that one. How else might I be able to start this one? What do you got, Luca?
You can add the square root of x plus 6 to the other side and then square both sides.
All right, so as we did earlier, we can still try and isolate one of our radicals. In this problem, we happen to have two radicals, though. So, Luca, which one did you choose to add over?
X plus 6.
That works, because it's negative already, make it a positive. So leave this alone, and then add this entire term over here. Now, why might that be a good suggestion, Luca? How does that really alleviate any issues that we were having a minute ago?
You can create like two radicals. The first side that I call is like this is good when you move it over. It sort of cancel out the didn't really work on that. Look, I was just thinking if you move that over, it cancel out the radicals or something like that. I didn't work on it, but I'm not sure I'm not done doing that.
Okay.
So
But you're on the right start. It's a good starting point. I would have started that the same way, because we could have tried to square both sides initially, and then we'd have to square the binomial, which meant we would have had to do this whole thing in the red there times itself. That's how we would have to square that before, which is really messy. But now that we're set up this way, it might be useful to try and square both sides, but in the setup that we currently have, it's a little easier. So let's take a look at this current setup and try and square both sides. So squaring this side, what happens? Just 2x minus 2. That's easy. But now, how do I square this right-hand side over here? There's a sum in the middle, right? So I can't just distribute the squares. What do I have to actually do, Niall? You answered this last time, that's why I'm asking you.
It's 1 plus root x plus 6 times 1 plus root x plus 6.
Okay, and it looks really messy at first, because you've got, looks like multiplying binomials, but we've done this already. We did this with binomial conjugates when you had to simplify. You've already done this. So go ahead and FOIL this out, please. Go ahead and FOIL this out. It's just going to be a little bit messy, that's all. But the end term drops the radical off, part of it at least. If you look below that little blue line I'm drawing right now, all right, that's what I end up getting if I were to FOIL this out. Does everybody agree with me? I'm showing all the steps right now. I know, you can be simplified still. Okay, but if you FOIL this out, 1 times 1 is 1. And outer gives you 1 times radical x plus 6, that goes here. Inner gives you 1 times radical x plus 6. And then root x plus 6 times root x plus 6 is really root x plus 6 squared. Well, what happens here? Yeah, and these two can be combined in the middle. Okay, so I'm going to simplify further now. The only reason students have trouble with these problems is because they're tedious. You have to do a lot of steps. There's a lot of room for error, so make sure you're being careful here. So this becomes 1 plus 2 root x plus 6 plus x plus 6. Again, these two combine right here to give you this. And then this one becomes this. That's the only simplification that I made there. Combine the middle terms, there's 2 of them, so you have a 2 out front as a coefficient now. But now what this helps me with is the following. I can move this 1 over, I can move this x, this 6 over here, I can divide by 2 if I want to, but I can get rid of this now by isolating this radical. So a minute ago we isolated the radical 2x plus, or 2x minus 2, and we got rid of it. But there's still a radical around the other one, so we got to get rid of it now. So let's move everything else over to the left-hand side except for that radical x plus 6. So moving over the 1, we subtract 1. All right, take a look up to make it easier. Subtract 1 makes it negative 3. Subtract 6 makes it negative 9. Then for the x, we subtract x from here, making this just x. And that equals 2 root x plus 6. Please try your best to simplify in one line. You guys are smart enough, I think at least, that you don't need to do this. If you really want to go slowly and do it one step, that's okay. But please, the 1 and the 6 is really 7. Subtract 7 from negative 2 is negative 9. And then 2x, subtract this x on the right-hand side makes this 1x. Now, again, would it be useful to divide by 2? Maybe. But then we'd have to square this side, which will put a 4 down here. So just leave it over here for now and square. And when you square this, this becomes a 4, and this is just x plus 6. Okay, so I wouldn't divide by that 2 in this case. I would just square both sides at this point. Squaring the left-hand side, I get this. Squaring the right-hand side, I get this. Okay, remembering to square the 2 out in front and to square the radical x plus 6, and then it's a little bit easier to solve. At this point, we've gotten rid of all of our radicals. We can just simply solve our trinomial. Let's see. X minus 9 becomes x squared minus 18x plus 81 equals 4x plus 24. Move terms over. X squared minus 22x. What is this going to be? It's going to be 61, 57. Plus 57 equals 0. This is not an easy one. And I'm just looking at my notes, so I picked up on it right away. But anybody pick up on what 57 is divisible by? 3. 3 times what number gives you 57? 19. And doesn't 3 and 19 give you 22 also? So the numbers, the factor, are going to be 3 and 19. All right, so use 3 and 19 here to solve this one, please. Which gets positive, which gets the negative?
19 is negative.
Why?
Because you have a negative middle term.
Oh, sorry, yeah, and the 3 is also negative. I'm sorry, I should have said that. They're both negative or they're both positive, I should have said. Yeah, because this is a positive, makes them both negative, or they're both positive. Since the negative is the middle, they're both negative. So we get 3 and we get 19 as our answers. Okay, x equals 3 and x equals 19. We got to check these in the original, right? Let's go ahead and check these in the original equation. All right, so the original equation, where was the original? We've got radical 2 times, I'll use 3 first, x minus 2 minus x plus 6 equals 1. So we got 2 times 3 is 6, 6 minus 2 is 4, square root of 4 is 2. Over here we've got 6 plus 3 is 9, square root of 9 is 3, we've got this equals 1. Is 2 minus 3 equal to 1? No, it's equal to negative 1. Okay, so this answer actually does not work. So this gets rejected. X equals 3. How about x equals 9? Let's plug a 9 in now real quick. Let's erase these spots and put a 9 in their place and see if it works. Put a 9 here and here. 9 plus 6, I'm sorry, 19, thank you. 19 plus 6 is 25, making this a 5 right here. 2 times 19 is 38. 38 minus 2 is 36. Radical 36 is 6. Is 6 minus 5 1? It is. So the second check does work. So this turns out to be our answer. So x equals 19 is our only answer for this one. Okay, x equals 19 is our only answer. Just beware of checking. Okay, again, I wouldn't recommend picking up or trying to memorize a pattern. Just check both your answers every time and see how they work. Okay, maybe when you do homework enough, you'll see that certain problems will have one of them that doesn't work, but you won't really know which one that is until you check anyway. So, to make it safe on yourself, just check each time. It says the following: solve the equation without squaring both sides. So, if you recall, a little while ago, I had told you isolate the radical and then go ahead and square both sides. So here, the problem is what?
Square both sides.
Yeah, you can't square both sides because the radical's not even, there's no variable in the radical, right? right? There's no x in the radical. So it wouldn't help to isolate the radical and square both sides. That would not help at all. What could you do instead? This is not obvious for this kind of a problem. It's a technique that's useful though. Sabine?
Isolate the radical and divide it by radical 5.
All right, so tell me what you would do. Go ahead. Give me your first line.
So I subtract 2 and move to the other side. And then I would factor out the right side, so it would be x times radical 5. And then I would
Okay.
divide all by radical 5.
And what that does is it gives you x, but it gives you x in terms of x, doesn't it? You're absolutely right that that seems mathematically sound. But the problem right now is that you can't have x in the answer for x, right? So that's the first way I would have done this. I would have done the same exact thing to start. Unfortunately, though, based on the way it looks right now, we can't really get an answer for x. Think about another way to do it, because there's multiple ways to take a look at this.
So could you subtract x radical 5 and then add 2 and then factor out take out the x?
Okay, so what Charles is saying is, instead of doing this first line, he's saying subtract the x minus 5 first. X radical 5 first. Giving us this instead. Okay, then what would you do?
Take out the x. You just remove out the x.
Leaving behind.
3 minus radical 5.
Do you see how that works now? So if x occurs in two places and you can't necessarily solve for it, get it on the same side and then factor it out as a GCF. Charles, what do I have to remember though? Can I leave my answer the way it looks right now?
No.
What do I have to do?
You have to isolate that.
Not isolate. What's the term?
Multiply by the binomial conjugate.
Multiply by the binomial conjugate. So we need to rationalize this by multiplying by 3 plus root 5 over 3 plus root 5. There are about 4 of you that really bombed this on the last test. I recall that the last 2 questions were on this, and there were a few people that got no points on those. You need to understand this. Let's go through it. So in the denominator, we have a radical, but we also have an integer value, and they're separated by a plus or minus, which makes this a binomial. A binomial that's irrational. Now, to get rid of that in the denominator, which we don't want, we need to multiply by the binomial conjugate. Conjugate means you have to switch the sign though. A lot of people kept this as a minus in the middle and tried it. And if you do that, it's not going to work. Your denominator still is going to have a radical. They have to have opposite signs. And let's go ahead and isolate this, or not isolate this, but analyze this a little bit further. The numerator, I just distribute the 2 to both, recalling that there's really parentheses around here, making this 6 plus 2 root 5. The denominator, though, I have to remember that I'm foiling this. What does that give me, Mike? If I FOIL that denominator out, what do I get? Negative 1? You got 9 here. 3 times 3 it looks like, right?
Yeah.
And then you got a plus 3 root 5 and a minus 3 root 5. Good. Then you've got a minus root 25, right? So what's it going to be? So first term, right, gives you 9. Inner or outer, either one first. This will give you 3 root 5. This will give you negative 3 root 5. Those, yeah. Okay. Where did the negative 1 come from? I was just trying to figure it out mathematically how you got negative 1 there. No biggie. All right. So as a result, we end up with this statement here. Now, that's after falling out fully. What could I do further? Why can I simplify this? What's in every term?
2.
2 is in every term. This is really what it is, right? If I were to factor out a 2 out of the top and out of the bottom, those 2's cancel. Okay, so my final answer is 3 plus root 5 over 2. You don't need to show this step here. If you're good enough, obviously, it's simplifying. So from here, you can go straight down to here. Take a 2 out by dividing all these by 2. Why am I not touching this root 5? Why am I not touching the root 5?
Because it's your variable.
Treat it like a variable. Very good, Ryan. Think of it like a variable. If this was 6 plus 2x over 4, the 6, the 2, and the 4 still reduce, but the x gets left alone. The root 5 is like a variable. Okay? Any questions on this? So it's going to get messy when you do your homework. It's not the easiest of questions because you're going to have questions like part B and part C from this example here, where you're going to have difficult problems where you have to square twice maybe, or you have to isolate a radical twice. Okay? You got about 7 minutes. Please get started on the homework. You probably did 3, 6, and 9 already, but after that, it's 12, 15, 18, 21, 25, and 28.